Hello, ladies and gentlemen. Today we are going to take a look at simplifying some rational expressions. So we're going to start our rational expressions unit, meaning we're going to continue some factoring, we're going to look at some fractions, and try to figure out what it means to simplify fractions, work with fractions a little bit more, as well as figure out how we do this algebraically with expressions that contain x's and x squareds and stuff. So you need your notes, something to write with. Calculating device is helpful, okay? So the whole idea today is we need to really understand how to simplify fractions that contain x's and such very accurately, okay? So I want to start with just a basic understanding of what it means to be a rational expression. That fancy word, ladies and gents, basically means that all we're talking about is a fraction or a ratio, okay? Ratios are fractions, hence the word rational in the word. Ratio meaning fraction. So we're talking about fractions that contain expressions made up of algebraic stuff. So basically the mathy definition says it's a ratio of polynomials, which means those are those things that have x squareds and x's and numbers, and on the bottom it would have one of those too. That's basically what a rational expression is. It's just a ratio made up of different polynomials. So how do we simplify them? Well, we're going to need to understand how to remember, or how to simplify basic fractions, or remember how to simplify basic ones, and then how to correctly cancel or divide out things. And then, yep, you know it, factoring is still going to be a part of what we do, okay? So let's take a look at a few examples, but first I want to take a look at just basic fraction idea simplifying fractions, okay? From what we know in our younger years, that when I simplify 10 over 12 or 10 divided by 12 and I go to simplify that fraction, you know the correct way to do it and you know the incorrect way to do it. When you simplify fractions, you're going to divide out something common from the top, and from the bottom. So you're going to divide out the number 2 and basically think about this 10 as 5 times 2 and the bottom is 6 times 2. So if I divide a 2 out of the top and bottom, I get a simplified fraction of 5/6. Notice what that looks like. I'm dividing the top and bottom by the same thing, so I can cancel their factors. I want to be careful to not cancel terms. This idea, well, 10 is the same thing as 10 plus 0, and 12 is 12, 10 plus 2. So I can just cross off the 10s on the top, and I'll end up with 0 over 2, which is just 0. So, 10 12ths is 0, basically. Not even close, okay? Just because something repeats on the top and bottom like this 1 in the 10 spot, meaning 10, doesn't mean I can cross it off and just say that's 0 over 2. I want to be careful to think about factors, things that multiply to make the numerator and the denominator, so that I can divide something out of the top and bottom. Hence the phrase, you can't cancel terms, but you can cancel factors. So let's take a look at some examples in there. Now this guy right here, be careful. People want to just start crossing random stuff off. We can't cross off anything. This is 40x plus 20. That's an expression where things are being added together. And the bottom is 10x plus 30. That's also an expression where things are being added together. In between there, this is a divide sign, ladies and gents. The only thing that cancels with division is multiplication. So I need to turn the top and bottom into multiplication problems. I need to divide or factor the top here, divide something common out of what they both contain, essentially. So I'm going to divide them both by 20, or factor out a 20, leaving me with 2x plus 1. On the bottom, I am going to factor out something these guys have in common, like a 10. I can divide a 10 out of both of those terms, which leave me with x plus 3. Now notice I've turned this expression into a multiplication fact. 20 times 2x plus 1, that quantity, is the same as 40x plus 20, but I've now turned it into multiplication. I have factored it. And that now means that I can cancel or simplify things. I can look at this 20 over 10 and say 20 divided by 10 reduces to 2 over 1, right? But this 2x plus 1, this guy, he's a factor. He doesn't cancel with anybody else. This x plus 3 stays on the bottom as such as well. There is no x plus 3 on the top to cancel with the x plus 3 on the bottom. There's a 2x plus 1, but those are two very different factors. They do not simplify. So this is my final simplified answer. Let's simplify this fraction. Well, what about the numerator? What can I take out of these two terms or factor out of these two? Well, I can divide them both by a 2 and an x, which gives me x plus 4, right? On the bottom, I just have 12x. There's no plus sign in there, so that's already just multiplication. I'm okay, I don't have to factor anything there. But notice how I have 2x over 12x right here. 2x over 12x, what does that reduce to make? It makes 2 over 12, which is 1/6, and x over x, those can cancel out, because you can divide an x out of both the top and the bottom. So all we have is 1/6. Now this x plus 4 right here, he's just going to remain there. He does not cancel with anybody else because he doesn't have a common factor on the bottom. Let's keep going. Simplify. What can I take out of the numerator here, the top? Well, I can take out a 2 and an x, right? So the numerator becomes 2x. And then if I take it out, it becomes x plus 5. On the bottom, this guy right here, what am I going to take out of that? Well, geez, can I divide them all by 3? No. Can I divide them all by an x? No. That means it's time to throw down the double parentheses. What goes in the front that multiplies to make 3x squared? 3x, x. What goes in the back to multiply to make 5? 5 and 1, right? So I have to decide, does the 5 go here? Does the 5 go here? Where does the 5 go? I think that 5 would go here. 1 there, check my inners, 1x, outer, 15x, yep. There's my factors. So on the top, I have 2x, x plus 5 in the numerator. In the bottom, I have 3x plus 1, x plus 5. So what I'm noticing is common in the numerator and denominator is the x plus 5. So basically, I can divide the top and bottom by the same thing to reduce the fraction, in essence, canceling out the x plus 5s. They are the same factor, so then I can reduce them. So all that's left is the 2x over the factor 3x plus 1, like so. Okay? Last time, here we go. Let's take a look at this guy. X squared minus 49. What can I do to the top here to break it apart? Well, I'm noticing 49 is a perfect square number. That's kind of handy. That leaves me with x plus 7 and x minus 7 for his factors. In the bottom, I want to break this guy apart. And check it out. They're all divisible by 2 first. So if I divide out a 2, it would become x squared minus 2x minus 35. So then I can break that piece apart into x, what multiplies to make negative 35 in the back, 7, 5. If I make the 7 negative, now they'll add to make negative 2 in the middle. That 2 is just going to hang out there. So this business right here, all factored out, is that guy. So I'm going to put that on the bottom of my fraction. So the top is all factored, the bottom is all factored, and now I look for common factors that will cancel. I have an x minus 7 on top with an x minus 7 on the bottom. So I now am left with x plus 7 over 2x plus 5. Okay? Now be careful, ladies and gents. This x and this x do not cancel each other out. This is a factor, all or nothing. Okay? You can't just cancel this 7 with the 5 or the 7 with the 2. It's everything. The whole factor has to go or nothing goes. Okay? We have x plus 7 over the top of 2x plus 5. That's my simplified answer. Okay? That's how we simplify these lovely expressions. We break them apart and we look for common factors that we can cross off or simplify out. Dividing out the top and bottom by those leave us with a reduced fraction. All right, I want to thank you for taking good notes. Kincaid out.